Welcome to this tutorial session where we are going to look at organic chemistry, and our focus will be on nitration of benzene. So let's get into it. Alright, so we're doing nitration of benzene. Alright, so when you're talking about nitration of benzene, we are just trying to add the nitrate to a benzene. So that is basically what we are trying to do with nitration. So it is just an addition reaction of adding this group to a benzene ring. So basically this is an addition reaction. No wonder we are saying we are just adding this group to a benzene ring. So the first step you need to consider when you are doing the nitration of benzene. So steps number one, you need first to start with, let me just steps to follow. So number one, it is the formation of an electrophile. Then apart from formation of an electrophile, you need now to do the nitration of the benzene. Right, so let's look at how we can do the nitration of benzene. So the first step, we'll start with formation of the electrophile. So what really happens here is that you are trying to react first the reagents. The reagents which are used when you are doing the formation of an electrophile, we use nitric acid, so you're going to react nitric acid with sulfuric acid. So these are the two reagents you use when you're forming the electrophile. So nitric acid with sulfuric acid. So how are we going to form this? We know that nitric acid, the formula for nitric acid, the chemical formula, it's HNO3. Then for sulfuric acid, it is simply H2SO4. So we are going to react this sulfuric acid with this nitric acid to form the electrophile. So let's start the process. So we are going to say nitric acid. You see, when you have something like this, HNO3, so you can also write this in form of, you can also write it in this form. You can say HO, then you write it as NO2. So this is what I'm going to write here. HO, then bonded to NO2, then plus, when you have something like sulfuric acid in this manner, SO2, H2SO4, you can write it also as, you can say H, you can start with H, then you say bonded to OSO3H. This and that way of writing is just one and the same thing. So I'll put it here, H bonded to OS, so SO3H. So let me get rid of this. So at this point, we are going now to react this to acids. So we know that this oxygen there has 2 lone pairs. Okay, so these lone pairs will first grab the hydrogen there. Then this bond between hydrogen and oxygen will eventually break. Then because oxygen is more electronegative, it will take with it the electrons which are between the bond. So when this happens, we are going to have H, or there on oxygen, it will grab that hydrogen. So we're going to have H there. Then we have NO2. Then plus what we are remaining with here, this bond, because oxygen has taken the electrons, this entire thing will be a base. So oxygen will take the electrons there, making it to be negative. So we'll have oxygen with a negative charge there, then SO3H. Okay, so we have that. So this is our base. Then we are trying to form an electrophile. So let's call this as step 1. Okay, so for step 2, let me use a different ink. Alright, so what we are trying to do here, we'll get rid of this water. You know that this water, and because this oxygen is bonded to 3 things, it must have a positive charge there. Okay, so this water now, we'll get rid of it. It will leave, and once it leaves, meaning that this nitrogen here will become positive, because the electrons there are going to neutralize the positive charge on this oxygen. So electrons there go to this oxygen, neutralizing its positive charge. Then the water will leave, leaving this to be positive. So this will be left NO2 with a plus. Okay, so the other product will be the water which left, so plus H2O, then plus the base which we had. So the base was OSO3H. So these are the product of this reaction. So these are the products. But you see, we are only interested in this plus NO2. This is the electrophile we are interested in. So we're interested in the electrophile. So now we are going to react this electrophile with the benzene ring. So this will be our step 2. Okay, so now the next step will react the benzene ring with this electrophile. So how do we do this? So we are just interested in NO2 plus. So let me use the next board. Okay. All right. So now let's now have the benzene ring. So the benzene ring we have is this one. With a double bond which are alternating. So plus what we had, our electrophile, which is NO2 plus. Okay, so that is plus NO2. Okay, so we have this double bond here. It will grab this electrophile. So this is going to happen. So when this double bond grabs this electrophile, let me just write the arrow nicely. Okay, so this double bond will grab the electrophile there. Then this is what it's going to form. Okay. So the electrophile is there. This double bond has been broken, so we should have a carbocation there, a charge. Okay, so we have a charge there, a positive, then the electrophile is attached at this point, the double bond is broken. So since we have this molecule, we can do what is known as resonance, because you see this double bond can shift to this point. Let me use a different ink. By just performing resonance, this double bond can shift to that point. Okay, let me do this. All right, so this double bond can shift to that point, and also that double bond can shift to that point. Hence, the charge there will shift to a different point. Or we can do this. Let's do this. We shift this double bond to this point. Then this double bond comes at this point, making this charge to shift there. So we can perform resonance. We use these arrows for resonance. So we can have a structure of this nature. So we'll have a double bond coming at this point. Then this double bond has come to this point. Then the charge has been shifted to that point, maintaining the position of the electrophile. So what we have just performed here is what is known as resonance. So with resonance just makes sure that the compound which you are transforming becomes stable. So it's just about making it more stable. No wonder we are performing resonance. Again, we can perform another resonance whereby we can have this structure. So this is resonance again. So the double bond, which is, let me use a different ink also here. Okay, so the double bond, which is here, can shift to this point. This double bond can shift to that point, making the carbocation to shift at that point. So you can perform resonance also here. So the carbocation will shift to this point, then the double bond will come to this point and also to that point. Okay, so this is another resonance structure, but we can perform a lot of resonance structures. So we can also have a carbocation coming to this point. Okay, let me use a different ink. This carbocation can also come to this point, so I can do the double bond shifting to this point, then this other bond can shift to this point. Okay, it can shift to that point, then this charge can shift at that point, that carbocation. So we can have another resonance structure written in this manner. So with an NO2 there, then the double bond can come there, then that bond can come there with a carbocation at this point. So you can perform a lot of resonance structures. So you can just draw like this, since it is undergoing a lot of resonance structure, or draw a circle inside, then we can put NO2 there. So this compound can undergo a number of resonance structures. Okay, so it can undergo a number of resonance resonance transformations until it becomes more stable. Okay, so from this, what we have, we can now make the final product. So these were just resonance structures. So we can now use one to form the product. Okay, so what we can do here, we can just do this. Mind you, remember this, we had this structure. We had the benzene ring like this, then we have NO2 there, then the double bonds are there. So we have the double bond there. Okay, so we have the double bond here. Okay, so we have a double bond there, and also we have here with a carbocation there. So we can now do what is known as deprotonation. Remember here there are 3 bonds, so meaning that one bond is for hydrogen. There is hydrogen at this point because carbon must be attached to 4 different things. So we can do deprotonation by using the base which we had, which is just the base which we had, which is okay. So I rubbed it. It was just OSO3. negative with H like this. So we can use this base to deprotonate that hydrogen. So what we are saying is this base, okay, so this base SO3H, which was negative, it has lone pairs of electrons, so it can be used to deprotonate this hydrogen. Then this bond will reform, so the double bond will be formed here. Once it is deprotonated, those electrons will be able to form the double bond there. Then what we are going to have is this structure. So I'm going to have a double bond there, another double bond there, and there with NO2. So what we have just done is that we have performed what is known as nitration. So this is basically nitration of benzene, and our product is actually this compound here. Alright, so don't forget to like, share, and also subscribe. Thank you.